Alright, this is number 29 on page 280, and this is a doozy, and it's just a doozy only because you have two expressions under the radical in one equation, and the variable is b, it's under both of them. You got to get it out of both of them. So you're going to work one at a time, and conceptually I don't think this is difficult, it just takes more algebra, more steps. So I decide, this is positive on the left hand side, I'm going to leave it and isolate this expression first. So I'm going to add the square root of 2b plus 5 to both sides. Okay, now in an effort to get the 3b minus 2 out of the radical on the left, I'm going to, because this is the square root of that, I'm going to square it to get the 3b minus 2 out from under the radical. So I'm doing the inverse of taking the square root. Whatever I do to the left, I do to the right, wrap and raise to the second power. Notice this is a binomial. This literally means 1 plus the square root of 2b plus 5 times 1 plus the square root of 2b plus 5. It's multiplied by itself. So on the left, of course, the 3b minus 2 will come out. And on the right, the pattern is, this is, like the a and this is the b. When I square a binomial, I always get the first term squared, which is 1, plus 2 times the product of these two terms. So 2 times 1 times root 2b plus 5. So 2 times 1 times the root 2b plus 5 plus the last term squared. So when I square the square root of 2b plus 5, I get 2b plus 5. Okay, so I've got one radical term left now, and I need to isolate that next. So I'm going to clean up the right side and then get everything moved to the left except for this expression here. So on the left here, 3b minus 2 equals 1 plus a 5 is a 6 plus a 2b plus 2 times the square root of 2b plus 5. So subtracting 2b from both sides, I'll leave a b on the left. Subtracting 6 from both sides, I'll have a negative 8 on the left, equals 2 times the square root of 2b plus 5. Okay, now, I could further isolate this radical by dividing both sides by 2, but I'd create a fraction on the left, and then when I squared it, I'd have a fraction, and I'd eventually have to get rid of that. So I can actually just leave it like this, and now raise both sides to the second power. So I'm going to wrap and raise that to the second power, and on the left I have this binomial b minus 8, and I'm going to raise that to the second power. So on the left I have b minus 8 times b minus 8, so I have the first term squared, minus 2 times the product of these two, so minus 2 times 8 times b is 16b, plus the last term squared, so 64, equals. On this, I have two bases. I have the 2, and then I have the square root of 2b plus 5. They both have to be squared. So 2 squared is 4, and when I square the square root of 2b plus 5, I get 2b plus 5. So I'm going to clean this up. It's going to be a quadratic equation. I'm going to get everything on the left set equal to 0, and look at factoring to solve. So subtracting 8b from both sides and subtracting 20. Okay, so I'm going to go to factor this. First terms are b. Factors of 44 that have a sum of negative 24, I'm thinking of 22 and 2. So negative 22b and negative 2b gets me my negative 24b in the middle. So my initial solutions are a positive 2 and a positive 22, but of course I'm going to have to check both of those in the original equation. So let's go with 2 first. The square root of 3b, which is 2, minus 2, minus the square root of 2 times b, which is 2, plus 5, equals 1. So this is a 6 minus 2, square root of 4, minus a 4 plus 5, square root of 9, equals 1. So does 2 minus 3 equal 1? In other words, on the left, 2 minus 3 is negative 1. Is that equal to a positive 1? No. So that means that what I substituted that 2, that it didn't work. So I have to purposefully reject that 2. It's an extraneous solution. That happens when we square things, when we're solving equations, when we manipulate and transform the original equation, that sometimes you get results that don't work in the original. So then the last thing to check would be the 22. So let's do that over here. The square root of 3 times 22 minus 2 minus the square root of 2 times 22 plus 5 equals 1. So this is 66 minus 2 under the radical, which is the square root of 64, minus, and this is 44 plus 5, which is the square root of 49, equals 1. Well, that's more like it. This is 8 minus 7 equals 1, positive 1 equals positive 1. So that 22 worked. So the solution to this is only b equals 22. All right, and that is it.